Hello there, and welcome to the Sleepy Science Channel. Tonight, we'll be exploring the lives of the largest animals that have ever existed. These are animals so immense, so strange, and so intelligent that they can seem almost mythical at first glance. They breathe air like we do, yet they vanish into depths that would crush most living things. They sing through the sea, they cross whole oceans, they carry history in their bodies, and move through a realm we still don't fully understand. We will travel through icy waters, open blue horizons, and the hidden depths far below the reach of sunlight. We will meet these gentle giants as they hunt, travel, and socialize, and we will explore their rich lives full of songs, culture, and family bonds. If you enjoy these gentle journeys, I invite you to like, subscribe, or share a thought below. It helps others find their way here, to one sleepy soul at a time. But for now, all you need to do is relax, let your body soften, let your breathing slow, and let your mind drift into the deep as we explore these remarkable creatures together. Let's begin. Blue whales. Of the largest animals Earth has ever known, nothing in the fossil record that we have found so far appears to exceed them. Not the tallest dinosaur, not the heaviest mammal on land, not even the great marine reptiles of prehistory. An adult can stretch longer than a basketball court is wide, and its body is built not for drama, but for astonishing efficiency. That is part of what makes it so captivating. This giant lives on tiny prey. It does not rule the sea with claws or teeth. It glides through the water with immense calm, gathering swarms of krill by the tongue. The scale of that contrast is almost hard to hold in the mind. The largest animal ever known survives by straining creatures small enough to rest on your fingertip. Once you realize that whales stop feeling like oversized animals and start feeling like one of the ocean's grandest impossibilities, some whales can sing across entire ocean basins. A whale does not need a horizon to send its voice in the sea. Sound travels far better than light, and the ocean can become a vast resonating chamber. Locals from the largest species can roll through the water for extraordinary distances when conditions are right. That means one animal may be broadcasting into a world far larger than anything we usually imagine. For a voice, it is not a cry thrown into empty space. It is a signal moving through pressure, depth, temperature, and current. To us, oceans often look silent from above. Beneath the surface, they can be full of layered cores, pulses and tones that carry far beyond human sight, that changes the feeling of the sea completely. It is no longer a mute wilderness. It becomes a place where an unseen animal can send music or message into the blue and touch another life unimaginably far away. Humpback whales invent songs, then entire populations copy them. That is one of the strangest things ever discovered in the animal world. Pattern begins somewhere in the ocean. A phrase changes, a sequence shifts. And over time, other whales adopt the new version until a whole population is singing something different from before. It is not random noise, and it is not fixed like a simple alarm call. It changes, spreads, and replaces older forms in a way that feels startlingly close to cultural transmission. Researchers have tracked these waves of musical change, moving from group to group across wide regions. The effect is almost unbelievable. You can picture one whale shaping a theme that others begin to echo until an ocean community carries the new arrangement onward. It makes the sea feel less mechanical and far more alive with shared behavior. These are not animals making sound only because they must. They are participating in something that evolves as it travels. A whale calf can drink hundreds of liters of milk daily. That sounds impossible until you remember how fast a young giant has to grow in the ocean. Infancy is not a tiny stage. It is a race to build blubber strength and endurance in a body that may one day weigh many tons. The milk must be rich enough to fuel that transformation, and it is. Whale milk is thick and packed with fat, more like a concentrated food than the watery image many people first imagine. Each day of feeding supports a dramatic physical change. A calf is not only surviving, it is rapidly becoming a stronger swimmer, a better diver, and a more capable traveler in a huge and demanding world that makes nursing in whales feel monumental rather than delicate. It is one of the great engines of ocean life. Somewhere beneath the surface, a mother is turning her own stored energy into the astonishing growth of a calf, destined to become immense. Some whales may live longer than 2 human lifetimes. That idea changes the emotional scale of a whale immediately. A very old whale may have entered the world before modern generations of people were born, and it may still be moving through Arctic water or open sea today. In bowhead, scientists have found evidence pointing to remarkable ages, making them among the longest-lived mammals ever known. Imagine what that means in practical terms. The same animal may have survived shifting ice-changing oceans, decades of storms, and a world transformed by human industry. Longevity on that scale gives a whale a kind of historical presence. It is not just old in the ordinary sense. It is a living witness to time that stretches beyond most personal memory, that can make even a brief sighting feel different. You are not simply seeing wildlife. You may be looking at a creature that has endured through eras of change while remaining part of an ancient rhythm. Older than our own whale harps can grow so large they rival the weight of small cars. The comparison is startling because it makes an internal organ feel suddenly real. A heart is easy to imagine. As a symbol, it is harder to imagine as a massive working engine inside a swimming body, the size of a building in the largest whales. That engine must move blood through an enormous network of tissue, while supporting long migrations, deep dives, and giant muscular strokes of the tail. When you picture a heart of that size beating steadily in dark water, the whale stops seeming like a simple enlargement of familiar life. It becomes something built to a different order of magnitude. Even the hidden machinery inside, it has crossed into a realm that feels almost beyond belief. Whales once walked on land before returning to the sea. This is one of evolution's most astonishing plot twists. The animals we now picture crossing open oceans began as 4-limbed mammals on land, and the evidence for that journey survives in stone. Early relatives show bodies that still carried the marks of terrestrial life even as they adapted to water over immense spans of time. Legs changed, spines flexed differently. Feet gave way to purpose, and the whole body became more suited to swimming than walking. The transformation is so dramatic that it almost feels like fiction. Its fossils reveal it piece by piece. What makes it especially captivating is that whales still carry echoes of that past. They are not sea creatures with no connection to us. They are mammals with a deep evolutionary history that turned back toward the water and committed completely. Once you know that every whale becomes more than an ocean giant, it becomes a living record of one of nature's boldest reinventions. The ocean changes chemically when whales rise, breathe, and dive. A whale is not only an inhabitant of the sea, it is also an active force within it. Each trip between depth and surface helps move materials through the water column, and those movements can influence the living systems around them. When whales feed below and return upward, they help bring nutrients back toward brighter layers where microscopic life can use them. That means a surfacing giant can be part of a larger ocean process that supports productivity far beyond its own body. Even waste becomes important here, because what leaves a whale can nourish the tiny drifting organisms that help power marine food webs. A whale is not merely passing through an ecosystem like a passenger. It is participating in the chemistry of the sea itself. The rise, the breath, the dive, and the return all become part of a hidden cycle that helps the ocean stay alive. Whales breathe air, yet spend nearly their whole lives underwater. A single fact makes them feel immediately strange and familiar at the same time. There are mammals warm-blooded like us, and every journey into the sea is bounded by the need to return for a breath. Yet they have turned that constraint into a way of life so complete that land is no longer part of their world. Their bodies carry the history of that ancient return to the ocean. They nurse their young, they surface to inhale, and they disappear again into a realm where most mammals could not last long at all. There is tension in every dive because the clock is always running. A whale is never fully free of the atmosphere above it. Even in the deepest silence below, there remains the future need to rise that gives whale life a rhythm unlike that of fish. Each surfacing is not just movement. It is a reunion with air, repeated across a lifetime. Sperm whales dive deeper than most submarines ever can. When a sperm whale leaves the surface, it enters a world with crushing pressure, total darkness, and cold that would challenge machines built by engineers. Yet this animal does it as part of its ordinary life. It descends in search of prey that live where sunlight never reaches, then returns carrying the memory of a place few humans will ever visit. There is something deeply compelling about that. We often think of the deep ocean as the domain of technology, but a whale reaches into it with muscle, blood, sound, and instinct alone. It does not descend as a visitor. It belongs there for a time. The image is unforgettable. A great head, a blunt body, and a tail driving downward into black water, deeper and deeper past the bright world of waves and weather. It feels less like a swim and more like a journey into another planet hidden below our own. Narwhals grow a spiral tooth that can reach astonishing lengths. At first glance, it looks like something borrowed from legend. A long ivory spiral projects forward from the head, so strange and so elegant that early sailors helped inspire stories of unicorn horns. But this is no ornament. In most males, and only rarely in females, it is actually an enlarged tooth that grows through the upper lip and continues outward in a left-handed twist. For a long time, people argued over its purpose. Now it appears to be sensitive as well as spectacular. The outer surface contains tiny tubules that can help detect changes in the surrounding water, including temperature and salinity. That means this famous structure may function partly as a sensory instrument. It can also be used in social display, and males have been seen crossing tusks in what looks almost ceremonial. Few animals make first contact with the imagination, so quickly fewer still remain this strange once science steps in. Bowhead whales survive in Arctic seas packed with moving ice. To live in the high Arctic is to live in a place that never stays still for long. The ice forms drifts, piles, cracks, and seals the surface with immense pressure. Yet bowheads have adapted to the shifting world so completely that they can move through regions many large animals would avoid entirely. Their bodies are wrapped in extraordinary insulation, with blubber that helps preserve heat and water cold enough to kill quickly. Their massive skulls are not just for shape, they can use them to break through thin ice in order to breathe, opening passages when none seemed available. Imagine the force and confidence that requires. These are not visitors skimming an edge of winter. They belong to one of the harshest marine environments on Earth. In darkness, cold and moving barriers of ice, they continue migrating, feeding, and raising young, carrying on the way of life that feels almost impossible from the comfort of warmer seas. Gray whales make one of the longest migrations on Earth. Each year, these travelers link radically different worlds with one long moving thread. Many spend summer feeding in rich northern waters, then turn south for breeding and calving in warmer lagoons and coastal regions. The round trip can stretch for thousands of miles, making it one of the longest known migrations by any mammal. What makes it especially captivating is how visible parts of this journey can be. In some places they pass so close to shore that people can stand on land and watch an ancient route unfold in real time. A gray whale is not wandering aimlessly through the ocean. It is following a seasonal map shaped by food, reproduction, and memory. For calves, the first great journey begins almost immediately after birth. That gives the migration a powerful emotional dimension. It is not only endurance on a grand scale, it is also inheritance, with each generation entering a path already written in movement. Orcas are whales, not fish, or not truly giant dolphins. They do belong to the dolphin family, but calling them giant dolphins can hide what makes them so distinct. Orcas are the largest members of that family, and their lives are shaped by a level of social complexity and ecological specialization that makes them stand apart around the world. Different populations hunt different prey, use different techniques, and keep different social traditions. Some target fish with astonishing precision, others pursue marine mammals in coordinated groups. These are not minor variations. In many cases, neighboring communities can live in the same waters and behave like entirely different kinds of predators. It is part of why orcas are so fascinating. A familiar black and white pattern may look consistent, but beneath that surface lies a world of cultural difference. Once you understand that the animal becomes harder to simplify. It is not just a famous marine hunter. It is a whole collection of societies, each shaped by learned ways of living. Berlin whales feed with comalic mouths instead of teeth. Inside the upper jaw hang long plaits made of keratin, the same basic material found in human fingernails. These plates fray at the edges into a dense curtain that can trap food while water escapes. The result is a feeding system unlike anything most people picture when they imagine a giant predator. There is no biting and no chewing in the usual sense. Instead, the whale takes in a huge mouthful of water filled with prey, then forces the water back out, while the baleen holds on to what matters. It is a beautiful example of scale transformed into design. A structure that seems simple at first becomes astonishing when you picture it at work in a massive moving body. Whole feeding lifestyles depend on slight differences in baleen shape and length. Some species skin others engulf. Each method turns the mouth into a living filter, and each makes the ocean's smallest creatures available to giants. Toothed whales hunt with sound in total darkness. For these hunters, darkness is not an obstacle in the way humans usually imagine it. It is simply a different medium of perception. Instead of relying mainly on vision, they produce focused clicks and listen for the returning echoes. From those echoes, they can gather information about distance, direction, shape, and movement. In effect, they create an acoustic picture of the world around them. That ability becomes especially extraordinary in deep or murky water, where sight offers very little help. A toothed whale can pursue prey in conditions that would leave us nearly blind, navigating by bursts of sound that strike an object and return with usable detail. It is hard not to find that astonishing. The animal is not merely hearing the ocean. It is actively probing it, asking question after question with each click, and receiving answers fast enough to hunt in water without light. Sound becomes something close to touch at a distance. Sperm whales have the largest brain ever measured. That fact alone is enough to stop most people for a moment. The heaviest brain known in the animal kingdom belongs not to an elephant, not to an ancient giant from the fossil record, but to a living whale that dives into black water to hunt. Of course, size by itself does not give a simple answer about intelligence. Brains are not trophies. What matters is how they are organized and what they support. Still, the scale remains deeply impressive because it belongs to an animal with a rich social life complex, communication and behaviors that suggest memory and coordination. There is something arresting about linking such a vast organ to a creature so difficult for us to observe in its full world. Most of its life unfolds out of sight, far offshore, and often deep below the surface. That hiddenness adds to the fascination. The largest brain ever measured belongs to a species we still know only in fragments. Thin whales are so fast, they were called the greyhounds. The nickname tells you something important at once. These are giants, but they are not slow-moving monuments of flesh fin. Whales are streamlined, powerful, and capable of remarkable speed for animals of their size. Early observers were so struck by that combination of length and swiftness that they reached for an image from land, comparing them to racing dogs. The comparison is imperfect, of course, yet it captures the surprise. A body that enormous should not seem quick, and yet it does. Their shape helps explain part of the mystery. Everything about them looks drawn out for movement, from the narrow profile to the clean sweep of the body through water. Watching one surface can feel like seeing velocity made graceful. This matters historically as well, because speed once helped some escape early hunters. For a time, they were harder to catch than slower giants. Even now, their movement gives them a distinct presence, leaner and more urgent than many expect. Right whales were named for the worst possible reason. The name sounds approving, almost affectionate, but its origin is grim. Whalers called them the right whales to hunt because they were especially profitable and tragically vulnerable. They tended to swim, slowly stayed near coasts, produced large amounts of oil and berlin, and often floated after death. In other words, the name reflects human convenience rather than anything admirable about the animal itself. Once you learn that the phrase becomes chilling, it turns an ordinary label into a small fossil of exploitation. This is one reason whale history matters so much. Language can preserve old attitudes long after people stop noticing what words once meant. In the case of right whales, the past remains painfully relevant because several populations were devastated, and some remain among the most endangered large whales on Earth. The name survives, but so does the warning inside it. Sometimes a species is introduced to us through the logic of those who nearly destroyed it. Some beaked whales vanish underwater for well over an hour. There is something almost ghostly about them. Beaked whales are among the least seen and least understood of all large mammals, partly because so much of their lives unfolds far below the surface for astonishing lengths of time. Some dives can last well beyond an hour carrying these animals into the deep ocean, where pressure rises and sunlight disappears entirely. Then after all that time, they return briefly surface with little fanfare and slip away again. That pattern makes them elusive in a very particular way. They are not rare merely because they live far from us. They are rare because they spend so much of their lives hidden inside a vertical world we barely witness. Even researchers can struggle to study them. The result is a kind of scientific mystery that still feels fresh in an age of satellites and drones. There are whales that can still disappear beneath the waves and leave us waiting, wondering what happened in the dark below. Whale ancestors once had ankles, toes, and hooves. That sounds wrong at first, because nothing about a modern whale suggests a hoofed animal. Yet the fossil trail points back to mammals whose limbs were built for life on land, and some of those early relatives carried unmistakable features in the ankle that link them to even-toed, hoofed mammals. This is one of those discoveries that rearranges your mental picture in an instant. The giant body moving through blue water is connected through deep time to creatures that once stepped on solid ground, not paddle-stepped. There is something wonderfully disorienting about that evolution did not simply make a sea creature from scratch. It transformed a land mammal stage by stage until the result looked almost unimaginable from the starting point. When you picture toes pressing into mud, then imagine the distant descendants crossing open oceans. The history feels less like a tidy diagram and more like a breathtaking act of biological reinvention. Ancient whale fossils still show tiny hind legs. Some of the most fascinating fossils are not the fully ancient-looking ones, but the transitional forms that seem to belong to two worlds at once. In certain early whales, the body had already become longer and more adapted for swimming, yet small hind limbs still remained. They were far too reduced to support life on land in the old way, but they had not vanished completely. That makes these fossils feel wonderfully unfinished, as if evolution had been caught mid-sentence. You can almost sense the old body plan fading while the new one takes over. For scientists, those little legs have powerful evidence. For everyone else, they are something even more memorable. They are a reminder that nature often changes through workable in-between forms rather than sudden leaps. The image lingers because it is so strange. A whale or something close to one, moving through water while still carrying miniature traces of a walking past on the rear of its body. Early whales swam like otters before becoming ocean specialists. The first whales were not born as sleek masters of the open sea. Some of them likely moved through the water in a far more mixed and experimental way, using limbs and body motion that would have looked more familiar in animals like otters or crocodilians than in modern whales. That matters because it makes the transition feel real. Before there were powerful tail flukes driving huge bodies through deep water, there were earlier forms testing a different kind of life at the edge of land and sea. You can imagine an animal still tied to shorelines, still carrying a body not yet fully redesigned. swimming with a style that worked well enough for the moment of the time. That temporary solution gave way to something much more specialized. The story becomes richer when you see it that way. The great ocean voyager did not appear fully formed. It began with awkward pioneers whose swimming was effective, but not yet the elegant mastery we know today. The nostrils of whales migrated upward into blowholes. This is one of the clearest and most astonishing transformations written into the whale body. Over immense spans of time, the nostrils shifted from the front of the face toward the top of the head, turning into the blowholes that modern whales use. At the surface, it sounds almost impossible until you see the fossil sequence, where skulls preserve this slow repositioning step by step. Once you notice it, the logic becomes obvious. An animal living more and more and more in water benefits from breathing without lifting the whole head awkwardly out of the sea. Yet obvious or not, it is still extraordinary. Few evolutionary changes are so easy to state and so hard to emotionally absorb. The face itself was reorganized. That means every surfacing whale carries a history of anatomical movement built into its skull. A blowhole is not just a convenient opening, it is the endpoint of one of the most striking redesigns in mammalian evolution. A whale blow is warm breath, not seawater. From a distance, the spout can look like the animal is spraying the ocean skyward. In reality, what you are mostly seeing is the forceful exhalation of warm air meeting colder outside conditions. The moisture in that breath condenses into the visible cloud, often mixed with a small amount of water sitting around the blowhole at the surface. That detail changes the scene in a subtle but satisfying way. The plume is not a fountain produced for show. It is the visible sign of a living mammal resetting its body after time below. Exhale first, then inhale quickly, then dive again. Once you know that every blow feels more intimate, it is breath made public over a great distance. It also helps explain why different species can sometimes be recognized by the shape and angle of the plume. What seems like a dramatic splash from afar is really the signature of a body that still depends. As all mammals do on air, whale ears are built to hear through water, not air. For us, hearing is shaped by life on land. Sound reaches our outer ears, travels through familiar pathways, and gives us a world organized largely by air. Whales inhabit a different acoustic reality. Their hearing systems are adapted for underwater transmission, where sound behaves differently and can travel with remarkable speed and reach that shapes skulls, tissues, and listening strategies in ways that make perfect sense for a marine mammal, yet feel almost alien from a human perspective. A whale does not simply hear the sea the way we might hear a pool or shoreline. It lives inside an environment where sound is one of the main ways reality arrives. That helps explain why noise pollution is such a serious issue for many species. To interfere with sound in the ocean is not just to add background disturbance, it is to interfere with one of the primary channels through which whales navigate, communicate, and understand the world around them. Deep-diving whales collapse parts of their lungs on purpose. To us, a collapsed lung sounds like disaster in some whales. It is part of the design. As the deep diver descends, rising pressure compresses air spaces in ways that help reduce problems linked to high pressure and dissolved gases. The lungs and rib cage are built to tolerate this process, and the body uses it as an advantage rather than suffering it as injury. That is one of those facts that turns a medical emergency on land into a survival strategy at sea. It reveals how different the diving mammal body can be from our own expectations. A whale does not defeat depth by resisting every force in some respects. It yields intelligently to that force, allowing compression where compression is useful. There is something elegant in that solution. The animal enters an extreme environment, not by remaining rigidly unchanged, but by having a body prepared to transform under pressure, then recover again when it returns toward the light. Whale blood carries oxygen with extraordinary efficiency. A long dive begins before the whale disappears beneath the surface. It begins in the bloodstream and muscles, where oxygen must be stored, protected, and delivered. with far more care than most land mammals ever need. Many whales have large blood volumes and high concentrations of oxygen-carrying components, allowing them to load the body for submersion in a way that supports prolonged hunting travel or descent. It is not traumatic in the visible sense. No one watching from a boat can see it happening. Yet it is one of the hidden reasons whales can do what they do inside the body. The chemistry has been tuned for a life that repeatedly separates itself from immediate access to air. That makes their dives feel even more impressive. The spectacle is not only in the surface roll of the vanishing flukes, it is also in the invisible preparation beneath the skin where the blood has already been readied for time spent far below the world of breathing. Some whales slow their heartbeat dramatically during deep dives. Picture the descent. The surface brightness fades, pressure climbs, and the body begins to conserve. One of the ways it does this is by reducing heart rate, sometimes to an astonishing degree, so oxygen can be used more carefully while the dive continues. It is a powerful reminder that deep diving is not just about strength, it is also about restraint. Whale does not charge downward with every system running at full pace. Instead, it shifts into a more economical state, preserving what matters for the time ahead that makes the descent feel strangely disciplined. A great animal is entering the deep by becoming quieter inside itself. The slower heartbeat is part of a broader physiological strategy, but even on its own, it is a remarkable image. The giant body moving farther from air is not panicking, and it is not rushing. It is settling into a controlled condition that allows life to continue. In a place where breathing is temporarily impossible, a diving whale can redirect blood toward its most vital organs. This is the kind of ability that makes the whale body seem not just impressive, but deeply strategic. During demanding dives, circulation can be adjusted so that the brain, heart, and other essential tissues receive priority, while less urgent areas get less. For a time, that selective distribution helps stretch limited oxygen stores and support survival during long periods below the surface. It is a reminder that a dive is not merely an act of holding breath. It is a whole body reorganization. The animal enters a different operating mode, one that protects the organs whose failure would end the journey. At once, there is something almost commanding about that image. A whale goes down into darkness, and the body quietly makes decisions about what must be sustained first. It feels like a built-in hierarchy of survival. In that sense, every deep dive is not just movement through water. It is a carefully managed internal campaign against time, pressure, and the absence of air. Berling is made from the same material as human fingernails. That detail makes one of the ocean's strangest feeding tools feel suddenly close to home. The great filtering curtains inside a Berlin whale's mouth are built from keratin, the same tough protein that forms our fingernails and hair. Yet in a whale, that familiar material becomes something on a far grander scale. It grows into plaits that can hang from the upper jaw like a dense living sieve. Along the inner edges, those plates fray into hair like fringes that help trap prey while water is pushed back out. So a substance we barely notice in daily life becomes in another body the key to sustaining some of the largest animals on Earth. That is part of what makes whale biology so captivating. Evolution keeps reusing old materials in startling new ways. Fingernail stuff becomes a feeding apparatus. Ordinary protein becomes a structure that lets giants harvest the sea by turning each mouthful into a patient act of selection. Raw-kill whales lunge feed by gulping whole patches of ocean. A raw cow does not nibble, and it does not peg. It accelerates toward a dense patch of prey, opens its mouth at the crucial moment, and takes in an engulfing mass of water and animals all at once. The throat pleats beneath the mouth expand dramatically, ballooning outward to hold a volume that can be astonishing relative to the whale's own size. For a moment, the body seems to transform from stringline swimmer into moving net. Then comes the hard part. The whale must force that water back out, while keeping the food behind, turning one explosive rush into a successful meal. It is a feeding strategy built from speed timing and elasticity. That is why it feels so thrilling to imagine. The largest motions are paired with tiny prey and exact judgment. A raw kill rushes through the sea, not like a passive giant, but like an athlete, launching a perfectly timed gulp at the richest part of the living water. A blue whale can engulf more water than its own body. That sounds like an exaggeration until you understand how dramatically the mouth and throat can expand during feeding. When a blue whale charges into a dense swarm of krill and opens wide the ventral grooves under, the jaw and throat unfold to an extraordinary degree. For a brief moment, the animal takes on a swollen, almost unbelievable shape as immense volumes of water pour in. It is one of the most extreme transformations of feeding animal commander go. The whale goes from sleek and streamlined to distended and cumbersome in seconds, all because the reward is worth it. Then the water is expelled and the trapped prey swallowed. What makes this so mind-bending is not just the volume involved, it is the fact that the living body can be built to handle such a dramatic shift, repeatedly without falling apart. A blue whale is not merely large, it is mechanically astonishing, able to turn its own size into a tool that briefly exceeds itself. Humpbacks use bubbles as tools to trap schooling fish. This is one of those behaviors that feels almost too clever when you first hear about it. A humpback, or a group of humpbacks, dives beneath a school of fish and releases streams of bubbles as they rise in a tightening circle. The result can be a shimmering wall that helps corral the fish into a denser cluster near the center. Once the prey is compressed and confused, the whales surge upward to feed. It is not just appetite, it is problem-solving expressed through motion timing and breath. The sea itself becomes part of the tool. That is what makes the scene so compelling. Nothing solid is built, and nothing is held in the hand, yet a structure appears anyway. A ring of bubbles becomes a temporary trap. In some places, whales even coordinate this behavior with remarkable consistency, showing that feeding can involve learned technique as well as instinct. It feels less like brute force and more like underwater strategy made visible. Some whales feed cooperatively with remarkable precision and timing. There is a special thrill in realizing that a meal can depend on choreography in certain situations. Whales do not simply gather in the same place and feed side by side. They act in ways that appear coordinated with individuals taking roles or matching one another, so the effort works better as a whole. The success of the hunt depends on placement timing and a shared sense of where prey will move next. That turns feeding into something larger than appetite. It becomes social performance with real consequences. Imagine several enormous animals, each committing to a fast, complex sequence in moving water, all while the prey tries to escape in every direction. When it works, the result is breathtaking. The whales achieve more together than one could easily manage alone. This matters because it shows that some feeding strategies are not just physical adaptations, they are also behavioral, ones shaped by experience and group living. The ocean in those moments becomes a stage for collaboration. Gray whales roll sideways to vacuum prey from seafloor mud. Their feeding grounds can look nothing like the open water scenes many people associate with whales. Instead of chasing schools in the bright upper sea, gray whales often search the bottom and shallow northern habitats, turning toward one side and driving their heads into soft sediment with powerful suction and filtering structures. They draw in mud water and small creatures that live buried in the seabed, then separate the food from the mess. It is a method that feels wonderfully earthy for an ocean giant. The whale is not just passing above the world below, it is plowing into it, stirring clouds of sediment as it hunts. This can even leave visible scars on the seafloor, like feeding traces written in underwater ground. There is something deeply memorable about that image. A migrating giant arrives in rich coastal waters and starts eating not from the sky-like expanse above, but from the hidden pantry inside the mud. It is whale life at its most unexpected. Sperm whales hunt giant squid in lightless deep water. Few predator and prey pairings feel more legendary than this one. Yet it happens in a real ocean beneath us far below the surface, where sunlight has vanished and pressure mounts. Sperm whales pursue squid that can grow to extraordinary size. We rarely witness these encounters directly, which only adds to their power in the imagination. Much of what we know comes from scars on whale-skin squid remains and the behavior of the hunters themselves. Circular marks left by scriptsuckers can appear on a whale's body like evidence from a hidden battle. That detail alone is unforgettable. It suggests struggle in a world we almost never see. What makes the hunt so compelling is the contrast between the silence of the deep and the intensity of the pursuit. Somewhere in black water, a mammal that breathes air closes in on a powerful invertebrate armed with grasping limbs, and one of the great unseen dramas of the sea unfolds. Beaked whales can chase prey far below some might's reach. The deep ocean is not empty, and beaked whales are among the specialists that prove it. They descend into cold, dark layers where vision becomes limited and the water above feels unimaginably distant. Then search for prey such as squid and deep water fish in that hidden zone. Their bodies are built for this demanding lifestyle, and their behavior reflects a level of diving commitment that makes them some of the most extreme mammalian forages on Earth. What is especially fascinating is how little spectacle they offer at the surface. They do not advertise their abilities with constant drama. They appear briefly, often quietly, then drop back into depths where almost all of the action happens beyond our sight. That contrast gives them a peculiar mystique. A modest surfacing can belong to an animal about to enter one of the most demanding hunting environments on the planet. Beneath that understated exterior lies a specialist of the deep equipped for pursuits most mammals could never attempt. Bowhead whales skimmed tiny prey with enormous curved baleen racks. Their feeding apparatus can look almost architectural. Inside the mouth hang extraordinarily long baleen plates, strongly curved and densely arranged, forming one of the most impressive filtration systems in any animal. As the whale moves through prey-rich water, with its mouth open, tiny drifting organisms are strained from the flow and concentrated for swallowing. This style of feeding is not explosive, like a lunging raw call attack. It is steadier, more like harvesting than ambushing. That difference matters, because it shows how varied whale feeding can be. Even among baleen species, bowheads are built for taking advantage of dense swarms of small life in Arctic waters, and their immense baleen helps them do it with quiet efficiency. The scale of the apparatus is part of the wonder. These are huge hanging structures inside the head of a whale, all devoted to capturing creatures that many people would barely notice in a scoop of seawater. It is giant anatomy tuned to tiny abundance. Different whale species can eat in completely different ways. This may be one of the best facts for opening the whole subject back up again. It is easy to imagine whales as variations on one basic design, all doing roughly the same thing with different sizes and colors. In reality, their feeding habits reveal a remarkable spread of lifestyles. Some filter swarms near the surface, some engulf prey in vast lunges, some comb the seafloor, some hunt with sound and darkness. Some work together, others specialize in different prey, depending on tradition and place. That diversity changes the emotional feel of whales. They stop being one kind of giant and start becoming a whole collection of experiments in how to live in the sea. Each species brings its own method, its own preferred world, and its own solution to the problem of finding food in a moving ocean. Once you see that pattern, the category expands. Whales are not a single story told many times. They are many stories sharing a name. Humpback songs can spread from one ocean population to another. This is one of the most astonishing examples of culture in the animal world. A new version of a song can begin in one humpback population, then move across vast stretches of ocean as other groups hear it and adopt it. Over time, an older pattern can fade, and the newer one can take its place not in one whale, but across entire regions. That means a change in sound can travel socially through the sea, almost like a wave of fashion or tradition. The scale of it is remarkable. we are not talking about a single call tied to alarm or hunger. We are talking about evolving sequences that spread between communities of enormous wild animals. It gives the ocean an entirely different character, somewhere beyond sight. One population is changing what it sings, and months later, another may be carrying that version onward. It feels less like instinct alone, and more like a living cultural current moving through open water. Sperm whales live in vocal clans with distinct dialect. A sperm whale group is not just a loose gathering of animals sharing the same habitat. In some cases, it belongs to a larger social world defined partly by sound. Researchers have found the different clans produce distinct patterns of clicks known as coders, and those patterns can help mark cultural identity. Two groups may occupy similar waters, yet sound different in ways that suggest separate traditions, rather than simple individual variation. That is what makes the idea so gripping. These whales are not only social, they may belong to communities with inherited ways of communicating, almost like accents or dialect systems carried across generations. Once you understand that the ocean becomes richer and more layered, a whale is no longer just a body moving through space. It is also a member of a cultural group, speaking in a style that reflects belonging. In the deep offshore world, identity may be carried not by clothing or symbols, but by sound patterns. In the dark, orca families keep cool patterns that last for generations. An orca family can be recognized not just by who travels together, but by how it sounds. Certain calls are passed down within family lines and remain stable over long periods, creating vocal traditions that help bind the group across time. A young orchid does not enter an acoustic blank slate. It grows into a social world already shaped by familiar sounds, and those sounds become part of what family means. That idea is powerful because it makes kinship audible. Imagine a lineage carrying recognizable call patterns year after year, decade after decade, so that identity is preserved not only in genes and behavior, but in voice. This gives orca society an emotional depth that is hard to ignore. The sea is not simply full of predators. It is full of families whose history can echo around them. When they call, they are not just exchanging information in the moment they are participating in a living inheritance that older relatives helped preserve. Some whales click louder than a jet engine. That fact sounds almost absurd until you remember how different sound behaves in water. Certain toothed whales can produce clicks of staggering intensity powerful enough to travel effectively through the sea and return useful echoes from prey or surroundings far away. These are not loud in the theatrical sense. They are functional, concentrated bursts built for a world where sound does the work that light often cannot. The comparison to a jet engine helps convey the scale, but the real wonder lies in what the animal does with that power. A whale sends out a sharp acoustic pulse into darkness, then listens for the returning trace of a squid, a fish, or the shape of the water ahead. Enormous force is being used for perception that turns sound into something almost physical in the imagination. The whale is not merely calling out, it is striking the dark with an invisible hammer and reading the answer that comes back. Whale songs have rhythm, repetition, and changing themes. That is part of why they can feel so uncanny to human listeners. A whale song is not just a single note repeated over and over, and it is not random noise drifting through the sea. It can contain patterns, phrases, and recurring elements arranged in ways that suggest structure over time. Parts repeat, parts shift, themes return in altered form. This does not mean whales are composing music in the human sense, but it does mean their sounds can unfold with a level of organization that our ears instinctively notice. That is where much of the fascination comes from. We hear something that feels partly familiar and partly beyond us. There is order there, but it belongs to another species in another environment. The result is haunting in the best way. A listener begins by hearing sound, then slowly senses pattern, and suddenly the ocean seems inhabited not just by animals, but by long-form acoustic performances moving beneath the waves. Scientists can sometimes identify individual whales by sound alone. To most of us, a whale voice might seem like a mysterious tone from an unseen distance. To research as listening carefully, it can sometimes hold clues about who is calling. Subtle differences in timing, pitch pattern, or click structure may help distinguish one individual from another, especially in species where calls have stable features. That possibility changes the whole feel of listening. The ocean stops being a place of anonymous voices and becomes a place where specific animals may be recognized through sound. It is almost like hearing footsteps and knowing who is approaching, except the medium is water and the signal may be traveling across remarkable distances. This kind of work also reveals how much information can be hidden inside what seems at first like a simple call. A whale does not need to be seen to become known. In some cases, listening is enough to suggest identity that makes marine research field part science and part patient act of acoustic acquaintance. Whale communication can travel farther when ocean conditions are right. The sea is not an empty hallway for sound. It is a shifting physical environment, and temperature, depth, and water structure can all affect how far a call travels. Under the right conditions, certain sounds can move with extraordinary reach far beyond what most people would guess possible. That means communication in the ocean is partly shaped by physics on a grand scale. A whale may call into water that carries the message efficiently for great distances, turning the surrounding sea into a kind of temporary long-range channel. This is one reason the underwater world can feel so vast and so intimate. At the same time, animals separated by enormous spaces may still be connected through sound if the conditions allow it. The ocean does not always behave the same way, so the range of a call is never just about the whale. It is also about the water itself, which can sometimes become a powerful accomplice in carrying a voice outward. A mother whale and calf often whisper to each other. That image sounds tender, and the science behind it makes it even more compelling. In some species, mothers and calves use quieter contact calls when staying close together, especially in situations where louder communication could draw unwanted attention from predators or disturbance. Instead of broadcasting boldly, they keep the exchange subdued and intimate. The effect is deeply moving because it reveals a side of whale life that is not about spectacle. Not every important sound in the ocean is grand or far-carrying. Some of the most meaningful ones are soft, close, and meant for one listener alone. A calf staying near its mother may be guided by those low-key exchanges through a huge and potentially dangerous world that makes the relationship feel immediate and vivid. Beneath all the scale and power of whales, there is also caution, closeness, and care. In a sea full of open distance, a mother and calf can create a private acoustic space of their own. Some whale calls are so low humans cannot hear them. That fact is a beautiful reminder that the ocean contains realities outside our senses. Certain whales produce calls at frequencies so low that they fall below the range of normal human hearing. The sound is there moving through the water, carrying information or presence. Yet to us it is silent unless technology translates it into something we can perceive that changes the emotional feel of the sea in a profound way. A human standing on a ship may think the surrounding ocean is quiet, while deep below, immense animals are exchanging signals in a register our bodies simply cannot receive. It is like discovering that a hidden layer of conversation has always been taking place around us. Silence was never complete. Our hearing was incomplete. Facts like that make whales feel larger than their visible forms. They inhabit not only distant water, but also an acoustic dimension that overlaps with our world while remaining mostly inaccessible to unaided human experience. A sea can become a library when whales start speaking. That idea captures something real about how much information the sounds can contain. A whale call may carry clues about species group identity, location, behavior, and social connection, while long-term recordings can preserve changes across seasons, years, and even generations. When scientists place listening devices in the ocean, they are not just collecting noise. They're gathering records of presence and pattern traces of lives moving through time. In that sense, a stretch of water can hold a history written in sound. One sequence of calls may reveal migration, another may hint at changing numbers or altered behavior in response to human activity. The image of a library fits because listening allows knowledge to accumulate. The ocean keeps an archive, and whales are among its most eloquent authors that makes every cool feel richer. It is not only a momentary sound vanishing into water, it can also be part of a larger record waiting for someone patient enough to learn how to listen. Whale carves a born tale first for underwater safety. In the underwater world, Earth has to solve a problem that land mammals never face in quite the same way. A newborn cannot begin life with its head exposed too early, because the moment the mouth and blowhole are free, the risk of inhaling water becomes urgent. Tail-first delivery helps reduce that danger by keeping the head inside the mother until the final stage of birth. It is a practical solution shaped by an aquatic life where the first moments matter enormously. The cafe enters a world of pressure motion and immediate vulnerability, and the body plan of birth reflects that reality. What makes this so fascinating is how clearly it shows the ocean rewriting mammalian life. Even the order in which a baby appears has been adapted to water. It is one more way whales feel both familiar and wonderfully strange. They share our mammalian beginnings. Yet even birth itself has been redesigned for the sea. A newborn whale must rise quickly for its first breath. The beginning of life is urgent. Once the calf is fully delivered, cannot linger below. It has to reach the surface and begin breathing air, often with help from its mother or other nearby whales that guide, lift, or shield it. During those first crucial moments that need gives whale birth a dramatic rhythm. One instant the calf is suspended in the hidden world below. Soon after, it must enter the atmosphere that all whales still depend on. First breath is not ceremonial. It is a threshold between two environments and a test that must be passed almost immediately. There is something unforgettable about that image. A new life enters the sea, yet the first great task is to reach the sky above it. That tension belongs to the heart of whale existence. From the first minute onward, every life is shaped by water below and air above, with survival depending on the journey between them. Mother whales nurse without lips drawing milk into seawater. At first, this seems impossible. On land, nursing is easy to picture because mouths conceal and milk can flow in a familiar way. Underwater, that arrangement would fail almost at once. Whale calves do not latch with soft lips like human babies. Instead, the mother releases milk from memory slits, and the calf takes it in, while positioned very close to her body. The process is adapted to a world where everything happens in moving water, and where wasted milk would mean lost energy. That is part of what makes it so captivating. A deeply mammalian act has been transformed into something both recognizable and completely strange. The intimacy remains, but the mechanics are different. You can imagine the calf swimming in tight alignment beside the mother receiving nourishment in a method refined for the sea. It is another reminder that whales did not abandon mammal life when they returned to water. They reinvented how to live it there. Whale milk is thick and rich, so it will not disperse in seawater. Ordinary milk would vanish into a pale cloud almost instantly. It would mix drift and become useless to a hungry calf. Whale milk solves that problem by being far thicker and richer than the milk most people picture. Its heavy texture helps it stay concentrated long enough for the calf to take it in, and its high fat content makes it an efficient fuel for rapid growth in a cold and demanding environment. That detail is easy to overlook, but it reveals how cleverly the ordinary functions of mammal life have been adapted for the ocean. Nourishment cannot be delicate when the surrounding world is always trying to wash it away. It has to be dense, durable, and worth the effort of producing. There is something wonderfully concrete about that the early life of a whale depends not just on maternal care, but on a form of milk physically designed to resist the dissolving power of the sea. Calves learn migration routes by traveling beside older whales. A migration is not just a line between 2 points on a map. For a young whale, it is a moving education. By staying with mothers and other experienced animals, calves begin to absorb the timing, direction, and geography of journeys that may stretch across immense distances. Currents, coastlines, feeding areas, breeding grounds, and safe passages all become part of a route, learned through participation rather than instruction in any human sense that makes migration feel less mechanical and far more alive. The path is carried in memory and behavior, then passed forward by travel itself. A calf does not need a chart. It needs elders already moving with purpose. There is something powerful in that image. Across open ocean, a young whale inherits a map not on paper, but in companionship. The knowledge is held in the group and in the journey, and each successful passage helps ensure the route continues into another generation. Some whale mothers fast while feeding their young. This fact reveals the extraordinary cost of motherhood in the ocean. In certain species, mothers give birth in regions where food is scarce or absent, and during that period, they may rely heavily on fat reserves built up earlier. Rather than feeding enough to support themselves fully, they are living on stored energy while producing milk and staying close to a growing calf that depends entirely on them. That gives early whale motherhood a heroic scale. The mother is not simply caring for her young in a comfortable nursery. She is paying for the cafes, beginning with her own body. Each day of nursing draws from reserves gathered months before in distant feeding grounds. There is something deeply affecting in that arrangement. The calm surface of a mother and calf traveling together can hide a major physical sacrifice. In the well world, nurture is not only tenderness, it is endurance planning and the ability to turn one season's abundance into another season's survival. Orca grandmothers can help entire families survive lean years. In many animals, age can become a disadvantage. In orcas, older females may become one of the most valuable members of the family. Research suggests that post-reproductive females can improve the survival of their descendants, especially during periods when food is harder to find. Their value may lie in knowledge, leadership, and the ability to guide relatives toward resources during difficult times. That makes the family structure feel astonishingly rich. Her grandmother is not just present in the background, she may help hold the whole group together when conditions worsen. This is one of those facts that reshapes how people think about whale societies. The benefits of long life are not only personal wisdom, can become ecological memory, can become survival. Picture an older female leading younger relatives through a lean season because she remembers what worked before. Suddenly, the ocean feels full, not just of instinct, but of experience carrying the family forward. Social whales may babysit calves within the group. In some species, care does not always come from the mother alone. Other group members may stay near calves, help them keep pace or remain with them, while mothers dive or maneuver in ways that would be more difficult without assistance. This kind of our parental care makes whale society feel more communal and layered than a simple parent-offspring bond. The calf may be growing up inside a network of watchful bodies rather than under one, guardian only that changes the emotional atmosphere of the pod. It suggests that social life has practical consequences and that cooperation can shape how the youngest members are protected and supported. There is something beautiful about that image. In the open sea, a calf is not left to face a huge world alone beside one exhausted parent. It may be buffered by a circle of companions, each contributing to the safe passage of new life. Through the group's moving world, young whales play, breach, and practice adult behaviors. Playing whales can look exuberant, even theatrical, but it may also serve a deeper purpose. A young whale that breaches tails, slaps, chases, rolls, or imitates adults is not only passing time, it may be developing strength, coordination, social confidence, and familiarity with the movements that later life will demand. That is one reason such scenes are so captivating to watch. Beneath the apparent joy, there may be rehearsal. A future adult is beginning to learn how its body works in water, how to interact with others, and how to perform the maneuvers its species depends on. This gives youthful energy a kind of narrative weight. The splash is not just a splash, it can be part of becoming in that sense. While childhood feels wonderfully relatable without losing its mystery, the ocean giant begins as a learner experimenting with motion and timing long before the full responsibilities of migration, feeding, and social life take hold. Family bonds and some whales can last for decades. This may be one of the most moving truths in all of whale life. In some species, especially highly social ones, close relatives remain associated for many years and sometimes for life. A calf may mature without leaving the family unit in the way many land mammals do, and adult sons or daughters can continue traveling with mothers long after reaching full size. That means a whale family is not always a brief nursery that dissolves once the young are grown. It can become a long-lasting society shaped by memory, loyalty, and shared experience. Over time, storms, migrations, hunts, births, and losses may all unfold within the same enduring relationships. There is something profoundly affecting about that these are not fleeting encounters in a wide ocean. They are lives braided together across years. Once you understand that a pod becomes more than a group moving through water, it becomes a history, carried by individuals who remain together. Orcas hunt in family groups with learned local traditions. An orca hunt is not always just a burst of instinct. In many populations, it is a family performance shaped by memory, practice, and place. Young orcas do not simply know every method from birth. They grow up watching older relatives and learning the specific tactics their group uses in local waters. One family may herd fish with tight coordination. Another may specialize in larger prey and use a very different approach. The technique belongs to the group as much as to the individual. That is what makes these hunts so mesmerizing. You are not watching identical predators repeating a fixed program. You are watching relative supply knowledge that has been preserved across years. The sea becomes a classroom and a stage at once. A calf stays close, observes, and slowly joins in. Over time, the hunt becomes part of its inheritance, not written in words, but passed along in movement, timing, and the trusted presence of kin. Not all orcas eat the same prey, even nearby. This is one of the clearest signs that whales can divide the world in ways humans do not expect. Two groups of orchids may travel through the same general region and yet pursue completely different meals. One population might focus heavily on fish, while another nearby targets marine mammals and largely ignores what the first group prefers. The difference is not trivial. It can shape movement, social behavior, hunting style, and even how often the groups associate with one another. In some places, these neighboring communities live almost like parallel societies, sharing the same coastline without sharing the same menu. That makes orcas feel far more complex than the simple image of a top predator. Appetite is not the whole story. Choice, tradition, and specialization matter. Once that sinks in the ocean, looks less like one habitat used in one way, becomes a mosaic of invisible cultural boundaries, each one influencing what a whale will chase. Some sperm whales babysit while others dive to hunt. That arrangement transforms a group of giant offshore animals into something unexpectedly familiar. In social units of females and young, not every adult may vanish into the deep at once. Some individuals can remain nearer the surface with calves, while others descend to hunt, creating a loose division of labor that helps the group function. This is a remarkable solution to a difficult problem. Deep foraging takes time, and young whales still need protection, company, and contact near the surface. By sharing responsibilities, the group can meet both demands at once. The image is striking because it reveals care woven directly into daily survival far from land. In open water, an enormous mammal is serving as guardian while relatives disappear below in search of food. It gives sperm whale society a layered texture. These are not isolated mothers, all managing alone. They are members of a communal system by cooperation. Helps make life in the deep possible. Humpbacks sometimes protect seals from attacking orcas. This is one of the strangest and most debated patterns in whale behavior. There have been repeated observations of humpbacks approaching scenes where orcas are attacking seals or other animals, sometimes placing themselves between predator and prey, or remaining nearby in ways that seem protective. No one can say with certainty that humpbacks understand every situation the way humans would. Describe it, yet the pattern is intriguing enough to demand attention. Why intervene at all, especially when the victim is not another humpback? Some scientists have suggested that responses shaped by defensive humpback calves may spill over into other contexts. Whatever the explanation, the behavior feels astonishing. A giant whale hears commotion arise and disrupts a hunt that does not directly involve its own kind. It makes the ocean seem morally stranger and more complicated than simple predator-prey stories allow. Sometimes a scene in the sea unfolds less like a machine and more like a drama with unexpected participants. Whale societies can carry culture, not just instinct. This is where whales become truly mind-opening. Culture means behavior shared through social learning rather than inherited only through genes. And in several whale species, there is growing evidence that traditions can persist, and shape how groups live. Sounds can differ, hunting methods can differ, preferred prey can differ, routes and social habits can differ as well. These differences are not always explained by environment alone. They can reflect ways of life passed from one whale to another over time. That matters because it changes the entire category of what whales are. They are not simply bodies executing ancient programming. They're also participants in communities where learning matters and shared habits endure. Once you see that every pod becomes more than a set of biological units, it becomes a society with memory. The ocean, in turn, becomes a place where traditions move through generations, without books, tools, or written language carried, instead by living relationships. Researchers have found evidence of menopause in some whales. That fact is astonishing because menopause is rare in the animal world, yet it appears in a few socially complex whale species, such as orcas and pilot whales. In these animals, females may live long lives after they stop reproducing, which raises an immediate and fascinating question: why would evolution favor survival beyond the reproductive years? One leading idea is that older females remain valuable because they help their families in other ways, especially through leadership experience and support for younger relatives. In other words, a female may stop producing calves while still increasing the success of the group around her. That is a profound shift in how many people think about animal life. It suggests that social value can extend far beyond direct reproduction. A whale may matter more, not less, because of what age has given her longevity, becomes a reservoir of guidance, and the family benefits from knowledge stored in a body that has already lived through many seasons. Female whales often lead with memory, not brute force. In some whale societies, leadership is not about the biggest body throwing its weight around. It can rest with females whose experience helps guide the group through changing conditions, difficult groups, or uncertain food supplies. This is especially striking in species where older females appear to play key roles in movement and decision-making. Their authority may come from knowing where to go, when to go, and how to respond when the familiar pattern fails. That makes leadership feel less like domination and more like stored history in motion. A whale that has survived many years may carry memories of lean seasons, hidden feeding grounds, or safe pathways others have not yet learned. There is something deeply compelling about that image. In a huge and shifting ocean, power can belong to the one who remembers the group, follows, not because she is loudest or most aggressive, but because her experience has become one of the family's most reliable tools for survival. Different whale groups can have traditions passed down like inheritance. When people hear the word inheritance, they usually think of genes or property. In whales, inheritance can also mean behavior. A group may pass along preferred calls, hunting techniques, travel habits, or social routines from older animals to younger ones so that a calf grows into a recognizable local way of life. That process is powerful because it creates continuity without anything written down. The young do not inherit only bodies, they inherit customs. This gives whale populations a depth that can be easy to miss from the surface. Two groups may look alike to us, yet they may carry different behavioral legacies shaped by their own histories. The sea, then, is not populated by identical members of a species. It is populated by communities with their own handed-down patterns. That is what makes whales feel so rich as a subject. Their lives are not reset with each birth. Something lived before continues onward, and the next generation receives it by growing up inside it. Some whales appear to cooperate even across species lines. The ocean does not always respect the tidy categories humans prefer. There are cases where whales seem to associate, respond, or act in ways that suggest cooperation beyond the boundaries of a single species. Sometimes mixed groups travel together for a period. Sometimes one species appears to react to the alarm or movement of another. In a few remarkable observations, large whales have even joined in mobbing or harassment responses against threats, in ways that seem to benefit more than one kind of animal. These events are not always easy to interpret, and scientists are careful about overreading them. Still, they are compelling because they hint that shared danger or opportunity can create temporary alliances in the open sea. That possibility makes where life feel even more layered. The ocean becomes a place where communication and response may ripple beyond a single family or species, producing moments of connection that seem almost diplomatic. In their complexity, whale lives can be social, strategic, and surprisingly political. That phrase may sound unusual for animals, yet it captures something important in many whale societies. Individuals do not simply drift in anonymous crowns. They belong to networks shaped by kinship, rank alliance, memory, and repeated interaction. Choices about who stays close, who leads, who helps calves, who shares danger, and who joins a hunt can all matter. Over time, these patterns create social worlds with tension, cooperation, and consequence. Not political in the human institutional sense, of course, but political in the broader sense that relationships affect outcomes. That is what makes whales so absorbing. A pod is not merely a cluster of bodies moving together because instinct says so. It can be a living arrangement where social knowledge matters every day. Once you start seeing that the ocean changes again, beneath the surface are not just giant mammals and dramatic dives. There are communities managing life through connection, choice, and a quiet complexity of living together. Whale poop helps feed the tiny life that feeds oceans. It may not sound glamorous at first, but this is one of the most astonishing ways whales shape the living sea. When whales release waste near the surface, that material can be rich in nutrients that microscopic organisms need in order to grow. Those tiny drifting lives, especially phytoplankton, form the foundation of vast marine food webs. So what looks like a humble biological detail becomes part of a much larger story. A giant whale rises from depth, empties its body, and in doing so, may help feed the smallest organisms in some lit water. Then those organisms help support everything above them in the chain, from zooplankton to fish, to seabirds and beyond. It is a beautiful reversal of scale. The enormous animal ends up nourishing life so small, it is almost invisible. Once you understand that a whale becomes more than a creature in an ecosystem, it becomes part of the system's ongoing fertility. By diving deep, whales move nutrients back towards some lake waters. A whale does not travel vertically through the ocean without consequence. When it feeds at depth and later returns to the surface, it helps carry elements from darker layers back into brighter ones. That movement matters because the upper ocean is where sunlight can power photosynthesis, and photosynthesis needs nutrients. In effect, the whale becomes a living shuttle between two different worlds of the sea. Down below, food is gathered up above. The byproducts of that life can help nourish microscopic producers that would otherwise be more limited. This gives every dive a larger ecological meaning. The journey is not only about the whale's own hunger, it is also part of a circulation system written into living behavior. Picture countless dives over years and generations, and the scale begins to feel extraordinary. A whale rises to breathe, but in a deeper sense, it is also lifting pieces of the dark ocean back toward the light. Whales can help support blooms of microscopic plankton. The word bloom sounds delicate, but in the sea, it can describe an explosion of tiny life that matters on a planetary scale. Phytoplankton are microscopic organisms that drift near the surface and use sunlight to grow. When the right nutrients are available, their numbers can increase dramatically. Whales can help make that possible by returning nutrient-rich material to upper waters where these minute organisms can use it. The result is a hidden partnership between the giant and the nearly invisible. That contrast is one of the most wonderful things in all marine science. The great body of a whale contributes indirectly but meaningfully to the flourishing of organisms too small to notice individually. Yet those organisms help support entire ocean systems. A bloom is not just a patch of greenish water. It is the beginning of food energy and chemical activity spreading through the sea. In that sense, whales can help encourage life at the very base of abundance. More whales can mean more life near the ocean surface. That statement carries a surprising ecological truth. When whale populations are healthier, the effects can extend far beyond the whales themselves. Through feeding, diving, surfacing, and recycling nutrients and upper layers, these animals can help support productivity in the waters where sunlight reaches and where much ocean life begins. That means in increasing whales may also help strengthen the conditions that allow other organisms to thrive. It is not a magical transformation, and it does not happen in the same way everywhere, but the principle is powerful. A sea with more whales can also become a sea with more support for the tiny lives that sustain larger ones. That gives conservation a more expansive meaning. Recovering whales are not only a success story about one group of animals, they may also be part of broader recovery in the living richness of the ocean surface, world where light, nutrients, and life meet in constant motion. Dead whales create deep-sea ecosystems that last for years. When a whale dies and sinks, the story does not end on the deep-sea floor. The body can become the center of a long, unfolding community. But first, scavengers arrive to feed on soft tissue. Later, other organisms take advantage of what remains, including nutrients locked within bones. Over time, the carcass supports a sequence of ecological stages, each with its own cast of creatures. This is one of the most extraordinary afterlives in nature. A single fallen giant can sustain life in a dark environment where food is often scarce and unpredictable. What makes it so compelling is the time scale. This is not a brief event that disappears in a day or two. It can remain important for years, turning death into a prolonged gift of energy for the deep in the ocean. Even the end of a whale's life can become the beginning. The body sinks out of sight, and an entire hidden world gathers around it. A whale fall can feed creatures never seen at the surface. The deep ocean contains animals so specialized and remote that most people will never hear their names, let alone see them alive. When a whale carcass sinks to the seafloor, it can provide food for some of these hidden creatures, drawing them from the darkness to a sudden concentration of organic wealth. Hagfish, strange crustaceans, deep-sea worms, and many others may take part in the feast. Some arrive quickly, others become part of the longer ecological succession that follows. The wonder of this lies partly in contrast at the surface. A whale is one of the most visible and charismatic animals on Earth. On the bottom, its remains may support beings so obscure that they seem almost invented. A single body links the familiar world of surfacing mammals to the alien world of the abyss. That connection is unforgettable. It reminds us that whales are not only important where we see them, they also matter in Rome's most human eyes will never reach. Some animals live almost entirely on the remains of whales. This is one of the strangest and most beautiful examples of deep-sea specialization. Certain organisms are so closely tied to whale falls that much of their existence depends on the arrival of these giant carcasses on the seafloor. Some worms, for instance, can exploit nutrients in whale bones in ways that make those remains more than food. They become habitat opportunity and the center of an entire way of life. That idea stretches the imagination in the best possible way. Somewhere in the dark ocean, the creature may be living out a life history made possible by the death of a whale it never encountered at the surface. It is a reminder that ecological relationships can be far more intimate and unexpected than they first appear. A whale's influence does not simply taper away after death. For some species, the remains are not an occasional bonus. They are the foundation on which survival itself has been built. Whales help move carbon through the ocean in hidden ways. When people think about carbon, they often picture forest smoke or the atmosphere above cities. The ocean's carbon story is just as important, and whales take part in it. While alive, whales store carbon in their bodies over many years. When they die and sink, some of that carbon can be carried down to the deep sea instead of returning quickly to the atmosphere. In life, they also influence nutrient cycles that support plankton, and those tiny organisms play a major role in drawing carbon from the air through photosynthesis. None of this turns whales into simple climate machines, and the science is complex. But the broader point is extraordinary. A giant marine mammal helps shape one of the planet's great chemical systems in ways most people never see. The power of whales is not only in their size or beauty, it is also in the quiet influence they exert on processes that reach far beyond the single animal. Protecting whales can benefit far more than whales alone. That is one of the strongest reasons whales matter so deeply. To protect a whale, you often have to protect migration corridors, breeding areas, feeding grounds, soundscapes, prey availability, and safer routes through human activity. In doing so, you are rarely helping one species in isolation. You are improving conditions for whole marine communities that share those waters, reduce certain dangers for whales, and you may also reduce harm to turtles, fish, seabirds, and countless lesser-known organisms. Protecting whales can become a way of protecting relationships, not just bodies. It is conservation at ecosystem scale. That is why whales hold such unusual power in the human imagination and in environmental work. They are large enough to inspire us, visible enough to focus attention, and ecologically important enough that their safety can have wider consequences. A whale becomes a kind of doorway. Step through concern for that one animal, and you begin protecting an entire living region around it. The ocean grows richer where giant bodies keep moving. There is something almost poetic about the truth of this. A whale crossing a sea is not just a traveler passing through empty space. It is a moving force carrying nutrients, staring ecological links, and connecting layers of the ocean through its ordinary life. Feeding in one place, servicing in another, migrating across long distances, and eventually even sinking in death. Each stage can enrich the world around it. The result is that a whale is never only itself, it is also a participant in the wider fertility of the sea that makes every migration feel larger than movement alone. A great body goes on its way, and life responds around it. Tiny drifting organisms benefit, food webs gain support, deep communities may one day be nourished as well. The ocean is not enriched by whales in one simple moment, but through a long chain of actions spread across time. Giants move, and the sea becomes more alive. Humans once hunted whales for lamp oil and industrial products. For centuries, a whale was not seen only as a living marvel. It was treated as a storehouse of useful materials. Oil rendered from blubber-lit lamps, lubricated machinery, and found its way into products that powered daily life long before electricity became widespread. That fact changes the emotional feel of whaling history. It was not only a distant maritime pursuit carried out by a few daring crews. It was woven into ordinary economies and ordinary rooms. Light in a home could come from the body of an animal taken far out at sea. Industry could turn more smoothly because a whale had been killed. Once you understand that, the scale of past hunting becomes easier to grasp and far more unsettling. The whale was drawn into human systems, not as a symbol, but as fuel, material, and commerce. A giant crossing the ocean could be reduced to usefulness, and that idea shaped centuries of human behavior toward these animals. Whale bones, oil, and baleen once shaped everyday human life. The influence of whales once reached far beyond ships and harbors. Berlin, the flexible material from certain whales' mouths, was used in items that needed strength with bend, including corsets, umbrella ribs, buggy, whips, and other manufactured goods. Oil illuminated homes and streets. Bones could be used in structures, tools, and displays. This meant whales were not just part of maritime history. They were built into the physical texture of ordinary human life. A person could get dressed, step outside, and move through a world quietly shaped by animals from the sea without giving it much thought. That is what makes this history so striking. The whale was not distant. It was present in households, clothing industry, and design. Once you start noticing that the past looks different, everyday convenience, elegance, and utility often rested on an invisible chain that stretched all the way from domestic life back to blood labor and killing on the ocean. Entire coastal towns rose because whales were being killed. Some communities did not merely profit from whaling now and then. They were built around it. Ports expanded, shipyards worked, warehouses filled, merchants prospered, and family fortunes rose because whales were being pursued, processed, and sold in certain places. The hunt shaped the rhythm of local life so completely that whole towns grew in identity and wealth around the industry. That gives whaling history a different scale. It was not only about single voyages and individual captains. It was about economies, neighborhoods, and generations of people whose livelihoods depended on the repeated destruction of giant marine animals. The sea fed the town, but through death rather than partnership. There is something haunting about that arrangement. A whale surfacing far offshore could be tied through trade and labor to a street, a business, or a household waiting on land. Coastal prosperity and ocean violence were connected more tightly than most people now imagine. Some species were pushed near extinction within human memory. This is not ancient history buried in a remote age. The collapse of some whale populations happened close enough to the present that it still lives within living memory and modern records. Industrial whaling intensified the pressure to such a degree that species once spread across broad oceans were reduced to a fraction of their former numbers. In some cases, the decline was catastrophic. The sea may have looked vast and inexhaustible, but human effort, once scaled up by modern ships and weapons, proved devastatingly effective. That fact carries a hard lesson: immensity does not guarantee safety. Even the largest animals on Earth can be driven to the edge if demand, technology, and indifference align against them. It also changes how we see the whales alive today. They are not simply timeless presences that endured untouched. Many are survivors of a very recent disaster, moving through oceans that still remember how close humans came to emptying them. The history of whaling is also a history of technology. First, the hunt depended on open boats and thrown harpoons, muscle wind, and astonishing risk. Crews had to approach an animal that could easily destroy the very craft chasing it. Later, the tools changed. Steam power, exploding harpoons, factory ships, and faster vessels transformed the balance. What had once been dangerous and limited became more systematic and far more lethal. That progression matters because it shows how technology can alter not just efficiency, but morality. In practice, a whale that might once have escaped by speed, weather, or sheer strength became easier to catch when machines reduced the old uncertainties. The hunt expanded because invention made killing more reliable. This makes whaling history more than a tale of courage or cruelty alone. It becomes a story about what happens when industrial capability meets a living resource. The ocean did not shrink, but it became more reachable, and that changed the fate of whales across the globe. Modern conservation began only after immense damage was done. There is a painful irony at the center of whale protection. By the time large-scale conservation took real form, many populations had already been devastated. Warnings came late, rules came late, and international action often followed decades of relentless exploitation. That delay matters because it reminds us how often humanity responds to ecological crisis only after abundance has already been broken. The whales were not saved at the moment of first danger. They were protected after loss had become undeniable. This gives modern conservation both its urgency and its humility. It is a noble effort, but also an admission of failure. We did not preserve innocence. We tried to prevent final ruin. That is why whale recovery stories feel hopeful and somber at once. Each protected animal represents a future still possible, but also a past that cannot be repaired completely. The first great era of protection was not a celebration of wisdom. It was a response to damage already done. Songs returned to some seas after hunting pressure eased. There is something deeply moving in that image. A place once stripped of many of its whales could over time begin to hear them again. As hunting pressure declined and some populations started to recover, researchers and listeners in certain regions recorded the return of whale sounds to waters that had fallen much quieter. The significance is more than acoustic. A song returning means bodies returning, migrations resuming, and a damaged living pattern beginning to reassemble itself. It is recovery made audible. You cannot always see population change directly, but you can sometimes hear the difference when the sea regains voices it had lost. That makes conservation feel wonderfully tangible. Success is not only a number in a report, it can be the reappearance of long patent sounds in places where silence had grown. An ocean that once seemed emptied begins to speak again, and the change carries both scientific meaning and emotional force. Whale watching became an industry where whaling once dominated. Few transformations in human history feel as symbolically powerful as this one in some coastal regions. Places that once launched hunts later began launching tours instead. The same waters that had supported killing became places where living whales drew visitors' income and wonder. That reversal is striking because it shows a profound change in value. The whale no longer had to die to become economically important. Its presence, movement, and charisma became enough. People would travel to see a blow a breach or the slow rise of a dark back against the sea. Entire local economies could benefit from awe rather than extraction. This does not erase the past, of course, and tourism brings its own responsibilities. Still, the change remains remarkable. It suggests that human relationships with whales are not fixed. Harbor can remember harpoons and then reinvent itself around binoculars, cameras, and the shared thrill of meeting. A giant still alive. Many whales still carry scars from ships and fishing gear, even after the great age of commercial whaling declined. Danger did not vanish. Modern oceans are crowded, noisy, and full of human infrastructure, and whales often bear the evidence on their bodies. Deep cuts from propellers, blunt force injuries from vessel strikes, and wounds from ropes or nets can leave lasting marks. Some whales survive these encounters and carry scars for years. Others do not. The tragedy of these injuries is that they often come not from deliberate hunting, but from ordinary traffic and equipment spread across seas humans now use constantly that makes the threat both familiar and difficult. A living whale may pass close to shore or through a shipping lane and meet a danger as human and mechanical as a highway collision. The scar becomes a record of contact between ancient life and modern industry. It tells us that protection is no longer only about ending hunts. It is also about redesigning how we move through shared water. Saving whales became one of conservation's most powerful symbols. Whales came to represent something larger than themselves. Their size, intelligence, beauty, and vulnerability made them powerful ambassadors for the broader idea that humanity could choose restraint instead of endless. Making campaigns to protect them helped to awaken public feeling, international activism, and a new language of environmental responsibility. This symbolic power mattered because it gave people a face, or rather a fluke, and a song for ecological concern. The whale became a creature through which millions could grasp the stakes of industrial exploitation and the possibility of recovery. That does not make the symbolism shallow. On the contrary, it helped drive real change. Laws were debated, treaties were formed, public pressure grew, scientific attention deepened. In that sense, whales did not only survive as animals, they also helped shape the moral imagination of modern conservation. To save them became a way of asking whether the living world could still be valued before it was too late. Blue whales were once louder because oceans were quieter. Imagine the open sea before engines filled it, with continuous mechanical sound. In that older ocean, a blue whale's low calls could move through a far less crowded acoustic world. The animal did not need to compete with the throb of shipping lanes, industrial traffic, or the broad wash of human noise that now overlays so many waters. Some researchers have suggested that in noisier modern seas, blue whales may not need to call as powerfully in every context, or that the changing acoustic environment has altered how and when their voices are used. That possibility is fascinating because it means the history of human industry may be written not only on coastlines and climate, but inside the soundscape of the largest animal ever to live. A quiet ocean once gave those cools more room to travel and more darkness to ring through. The great voice of the blue whale belonged to a world that personically emptier than ours. Ship noise can interfere with how whales communicate to us. A passing vessel may sound temporary, just another distant engine crossing the water to a whale, especially in a busy corridor. That noise can become part of the constant background against which life must now be conducted. Communication depends on sounds being heard clearly, and heavy ship traffic can mask calls reduce their effective range or force whales to adjust their behavior in ways that cost energy and clarity. Some may call louder, some may change timing, some may lose contact more easily in the acoustic clutter that matters. Because sound is not a luxury for whales. It helps them maintain social bonds, find one another coordinate, and understand the surroundings. When human noise fills the sea, it can shrink the acoustic world available to them. The tragedy is that this often happens invisibly. A ship passes the surface, closes behind it, yet below whole conversations may have been shortened, blurred, or pushed aside. Some stranded whales show signs of sun-related trauma. This is one of the most troubling modern whale mysteries. In some unusual strandings, especially involving deep-diving species such as beaked whales, researchers have found patterns that suggest a possible connection to powerful naval sonar. The idea is not that every stranding has the same cause, because strandings can happen for many reasons. The concern is that intense sound may sometimes disturb whales so severely that they alter their diving behavior in dangerous ways, rising too fast or fleeing into confusion. In certain cases, tissue findings have hinted at injuries consistent with rapid pressure-related stress. That possibility makes the story deeply unsettling. A technology designed for human detection may be affecting animals whose lives depend on exquisite control of depth and sound. The sea becomes a place where an invisible pulse can trigger panic far below the surface. Few threats feel stranger than that. Nothing touches the whale directly, yet the consequences may still be grave. Climate change is altering the routes whales have used for ages. A migration may look timeless when seen from shore, but it depends on conditions that are never fully fixed. Water temperature, pre-availability, currents, sea ice, and seasonal timing all shape where whales go, and when they go there as the climate changes. As long-established patterns can begin to shift, food may appear earlier, later, farther north, or in different concentrations. Ice edges may move, familiar stopovers may become less reliable. The result is not simply that whales travel through warmer water. It is that inherited routes may no longer match the ocean they now encounter. That makes climate change feel immediate in a very personal way. A whale following an ancient pattern may arrive in a world that no longer behaves as expected. The path still exists in memory, but the sea is changing beneath it. New ideas capture our moment more sharply than that. Even great migrations can be thrown into uncertainty when the planet's old timing starts to slip. Melting sea ice is changing Arctic whale world rapidly. For Arctic whales, ice is not just scenery. It shapes movement, access, risk, timing, and the very structure of the habitat. When that ice changes quickly, the entire world of these animals can shift with it. Open water may appear where there was once barrier or shelter. New routes may become possible. New competitors and predators may move farther north. Human ships may enter regions that were harder to reach before. Prey patterns may also change as the physical system rearranges itself. This is what makes Arctic transformation so profound. It is not one simple problem with one simple consequence. It is a rapid rewiring of a whole marine world. For species adapted to icy conditions over long stretches of time, the pace of change can be especially challenging. The Arctic can still look vast and severe to us, yet within it the rules are moving. A whale built for that world must now live inside one of the fastest changing environments on Earth. Fishing lines can trap whales for months or years. Entanglement is one of the cruelest dangers whales face because it often unfolds slowly. A line may wrap around the mouth fins or tail and remain there as the whale continues trying to swim, feed, dive, and migrate. The gear can cut into flesh, create drag, restrict movement, and drain energy over time. Some whales manage to survive for long periods in this condition, carrying ropes and injuries through the sea for months or even years. That endurance is astonishing, but it is also heartbreaking. The animal is still alive, still moving, still trying to live its ordinary life, yet every action has become harder. This kind of harm also reveals a harsh truth about modern notions. A whale does not need to be hunted to suffer from human systems. Lost or active fishing gear can become a persistent trap in waters the animal has used for ages. The danger is quite durable and often terribly hard to escape. Ship strikes are now a major danger for several species. A whale can survive storms, migration, hunger, and vast distances, yet still be killed by something as blunt and ordinary as a collision with a fast-moving vessel. This threat is especially serious for species that travel through busy coastal routes or feeding grounds that overlap with shipping traffic. Danger can be easy to underestimate because it leaves so little drama visible from afar. A ship may continue on the ocean surface, may show almost nothing, but for the whale, the impact can mean broken bones, internal injury, propeller wounds, or sudden death. This makes modern risk feel chillingly mundane. The problem is not one extraordinary event. It is repeated overlap between ancient animal pathways and industrial transport networks. For some species, that overlap has become a leading conservation concern. The whale rises to breathe in waters it has every reason to trust, and in that ordinary act, it may meet one of the deadliest consequences of the human maritime world. Even remote whales can be affected by plastic and pollution. Remoteness no longer guarantees safety. The ocean moves materials across huge distances, and pollutants introduced far from a whale's habitat can still find their way into food webs, tissues, and remote waters. Plastics break into smaller fragments. Chemical contaminants travel through currents and accumulate in prey. Even whales living far from cities and coastlines can encounter the reach of human waste through what they eat and where they travel. That is what makes modern pollution so disturbing. It does not stay politely near its source. It spreads. A whale in a place that looks untouched may still carry traces of industrial chemistry or ingest debris connected to a human world it never sees. This changes the emotional scale of environmental damage. The problem is no longer local mass alone, it is planetary seepage. The great distance between human activity and a remote whale can feel enormous to us. Yet in the ocean, the distance is often far less protective than it seems. Scientists track whales from space, sound drones, and skin samples. Whale research today can feel almost wonderfully improbable. A giant animal in the open ocean might be studied from orbit, detected through underwater microphones, photographed from drones overhead, and analyzed through tiny samples of shed skin or biopsy tissue. Each method reveals a different side of the story. Satellites can help spot bodies or track environmental patterns around them. Acoustic monitoring can reveal presence when nothing is visible at the surface. Drones can measure body shape and health from above. Skin samples can provide clues about genetics, hormones, diet, and pollution exposure. What makes this so exciting is the contrast. The subject is ancient, immense, and elusive, yet the tools are among the most advanced humans have built. It feels like science stretching outward in every direction to understand beings that still spend most of their lives beyond our reach. The whale remains mysterious, But now the mystery is being approached through a remarkable alliance of technologies. Each whale carries clues about the changing state of oceans. A whale is not just a single life moving through the sea. It is also a living record of the world it has passed through. Its body condition can hint at food availability. Its scars can reveal encounters with ship's predators or fishing gear. Its chemistry can reflect pollution exposure. Its movements can show where prey has shifted or where habitat conditions are changing. Even stress hormones in skin samples can offer insight into pressures building within the wider ocean system. That is what makes whales such powerful indicators. They integrate the story of vast marine environments into bodies we can sometimes observe and study. A single animal may carry traces of warming water, altered food webs, industrial noise, and human traffic all at once. In that sense, looking closely at a whale can become a way of reading the ocean itself. The giant moving of the surface is also a messenger bearing evidence of how the sea is changing around it. The blue whale's tongue can weigh as much as an elephant. That comparison lands with such force because it makes one body part feel like a creature in its own right. Inside the mouth of the largest animal ever known sits a tongue so immense that its weight can rival that of a full-grown elephant. It is not there for some decorative marvel. It is part of a feeding system built on extraordinary scale, helping manage huge volumes of water and prey during each engulfing rush. The fact becomes even more astonishing when you imagine it in motion, inside a living mouth opening wide in the sea working, as part of a mechanism large enough to reshape your whole sense of animal anatomy. We are used to thinking of size in terms of whole bodies. Here, even a single organ feels monumental. That is why whales keep surprising us. You begin with one astonishing animal, then discover that inside it the parts can sound almost as impossible as the whole. Sperm whale's head holds an enormous chamber of waxy oil. Few animals carry anything stranger in their bodies. The great block-shaped head of a sperm whale contains a vast organ filled with a waxy substance, once called spermaceti, and for centuries, people puzzled over what exactly it did. Even now, some questions remain, which only adds to the fascination. Scientists have proposed roles connected to some production buoyancy control, or both, though the acoustic function is especially important in current understanding. What makes this so gripping is the sheer oddness of the design. A deep-diving hunter of squid crosses the ocean with a huge reservoir of specialized material, filling much of its head as though evolution had solved a difficult problem with a structure no novelist would dare invent. The head becomes more than a skull. It becomes an engineered chamber inside a living giant. Once you know that the sperm whale seems even more improbable, like a creature assembled from mysteries that somehow work perfectly. At sea, some whales sleep with only half their brain at once. That sounds like a superpower, but for a whale, it is a practical solution to a difficult problem. A mammal that lives in water cannot simply sink into deep unconsciousness for long periods the way many land animals can. It still needs to surface breathe and remain alert enough to keep moving through an environment where total shutdown could be dangerous. So in some species, sleep appears to involve one hemisphere of the brain resting while the other remains more active, and the pattern can switch. This means rest comes in a form that allows the animal to keep enough control over breathing and awareness to survive. It is one of the most elegant examples of nature refusing to choose between two necessities. The whale does not stop being a mammal, and it does not stop being a creature of the sea. Instead, it sleeps in a way shaped by both. Even rest becomes an adaptation to ocean life. Whales can breach completely clear of the water despite their size. There is a special thrill in seeing something enormous, as though gravity has momentarily lost its authority. A breaching whale can drive upward with such force that its whole body clears the surface before crashing back down in a towering explosion of foam. The sheer physical power involved is almost difficult to believe. Water is heavy, bodies are heavy, and whales are among the heaviest bodies on Earth. Yet muscle momentum and intent can combine to launch that mass into open air. I wonder people who witness it rarely forget the moment. It feels like a contradiction made visible. A creature built for the sea suddenly becomes airborne. Scientists still debate all the reasons for breaching in different contexts, including communication play, parasite removal, or social display. But even before explanation, the act has its own force. It reminds you that a whale is not merely large. It is dynamic, explosive, and capable of astonishing feats of motion. Barnacles and lice can travel the oceans on whale skin. A whale is not only an animal, it can also be a moving habitat as it travels across seas and through different climates. Other organisms may cling to its body and make the journey with it. Barnacles attach to the skin and grow there, while whale lice, which are tiny crustaceans, despite the name, can live among folds, scars, and rough patches on the body. This turns the whale into a kind of drifting world, carrying small passengers across immense distances. What makes that so captivating is the layered scale of it. A giant crosses an ocean, and on that giant ride creatures small enough to be overlooked living their own entire lives. On the surface of another being, the whale becomes both traveler and landscape. Even its skin is not always just skin. It is a place where attachment, shelter, and motion come together. The open sea looks emptier until you realize how much life can be moving on one whale alone. Whale skin can shed fast, especially in cold feeding grounds. Skin might seem like an ordinary detail until you remember how much a whale's outer surface has to endure. It meets cold water parasites, constant motion, and long migrations, and in some species, the skin can renew and shed at surprisingly rapid rates. In colder feeding grounds, this process may become especially important, helping remove fouling organisms and maintain a healthier outer layer. Some whales even appear to seek particular habitats that may help with skin maintenance, turning parts of the ocean into something like seasonal care stations. That idea is wonderful. Vivid. A giant marine mammal is not simply roaming for food. It may also be managing the condition of its own body. Through where it goes and how its skin responds, the whale becomes less like a passive creature drifting through water and more like a living surface in constant renewal. Even the outermost layer is dynamic, adapting quietly to the demands of an enormous life at sea. A narwhal's tusk can sense changes in the surrounding water. That spiral tusk is already one of the most arresting structures in the animal kingdom, but its real wonder may lie in sensitivity rather than spectacle. Research suggests that the tusk contains pathways that allow it to detect aspects of the external environment, including changes in temperature and salinity. In other words, this famous protruding tooth may function partly as a sensory organ that transforms the whole image. What looks like a fantastical weapon or ornament may also be a way of reading the Arctic world. The narwhal moves through cold water, carrying an instrument that extends from its head into the environment, almost like a living probe. It is difficult not to find that extraordinary. The animal seems to belong halfway between biology and legend, yet the science makes it stranger rather than plainer. A spiral tooth that senses the sea feels exactly like the kind of idea nature should not be able to invent, and yet there it is. Belugas are among the most expressive whales on Earth. Part of their charm lies in how visibly their faces seem to change. Unlike many whales, belugas have flexible necks and pronounced melon structures on the forehead, which can shift shape as they produce sounds and move. The result is an animal that often appears animated in a way people immediately respond to. After that, their rich vocal lives, whistles, chirps, and varied calls, and it becomes easy to see why belugas have been called the narrows of the sea. They seem lively, responsive, and unusually communicative, as though more of their interactivity rises to the surface than in many other whales. This does not mean they are little ocean clowns. It means their bodies reveal a remarkable blend of mobility, sound, and social presence that feels highly expressive to human observers. In icy northern waters, these pale whales can come across not as silent giants, but as vividly social beings with faces that seem almost conversational. The smallest whales are tiny beside the giants they resemble. One of the best ways to appreciate whale diversity is to remember that not all of them are leviathans. Some of the smallest species, such as dwarf sperm whales and other humpback cetaceans often grouped in everyday speech with whales, can be astonishingly modest in size. Compared with the ocean's giants, set beside a blue whale, they can make the whole category feel elastic almost beyond belief. This matters because it frees us from imagining whales as one scale repeated over and over. The whale world includes extremes. Some species have the size of a large bus. Others are small enough to feel almost delicate by comparison. Yet even the smaller ones carry the same broad inheritance of mammalian life in the sea, with blowholes specialized bodies and remarkable adaptations of their own. That contrast is part of the wonder the word whale can point both to the largest animal ever known and two species, tiny beside it all within one extraordinary lineage. The more we study whales, the stranger and grander they become. That may be the most satisfying truth of all. Usually when we learn more about something, a little of the mystery falls away. With whales, knowledge often has the opposite effect. The closer science looks, the more astonishing the picture becomes. The history reaches back to hoofed ancestors on land. Their societies can preserve traditions. Their voices travel through whole seascapes. Their bodies solve problems of pressure, darkness, cold, distance, and family life in ways that keep surprising us even now after centuries of study. They continue to challenge easy categories. They are mammals, yet live almost entirely at sea. They are immense, yet often feed on tiny prey. They are familiar enough to stir emotion, and strange enough to feel nearly mythical. That combination is rare and powerful. It is why whales never seem to shrink under explanation. They expand. Each answer opens another door, and beyond it, the ocean somehow feels larger than before. As we come to the end of our journey, the ocean feels a little different now. We began with giants beyond imagination, creatures, larger than any animal that has ever lived. We drifted through deep waters, where whales dive into darkness, and across open seas, where their voices travel farther than we can see. We followed ancient migrations, met families shaped by memory and tradition, and globes, lives that unfold far below the surface in ways both powerful and delicate. Along the way, the world of whales revealed itself as something far richer than size alone. It is a world of sound, of learning, of endurance, and of connection. A world where even the smallest drifting life can be linked to the movement of the largest bodies on Earth. Now, as all of that settles, you might begin to feel the scale of it soften into something quieter. The vastness remains, but it no longer feels distant. It feels steady, rhythmic, almost like the slow rise and fall of the sea itself. If you are still awake, there is always another gentle journey waiting for you on the screen. And if you found something here that you enjoyed, you can always subscribe, or leave a quiet thought below. It helps this calm little corner of the world reach others who may need it. For now, there is nothing more to follow. Let your breathing slow, let your thoughts drift like currents, and let the ocean grow still around you. Sleep well, and good night for you.